Hello, this is ClayMoseley, and this is my presentation on horizontal directional drilling, or HDD as it's known in heavy industrial construction. This presentation will cover the advances in techniques and applications and some of the cost-benefit analysis and what it's used for in general. HDD is not exactly a new technology, although there are a lot of innovations that have come about just in the last 10 or 15 years. Horizontal directional drilling can trace its roots all the way back to 1891, with the first patent given for non-vertical drilling equipment to John Smalley Campbell, and the patent number is 459,152. The first non-vertical well was actually drilled in 1929 near Tucson, Texas, upon the realization that wells are not actually vertical. Actual slant drilling began in the 1930s, and there were a couple of others in Pennsylvania in the 1940s, in fact. The 1970s saw the development and usage of what's called downhole or mud hydraulic driven motors, which advanced capabilities and control. Modern telemetry and drill head guidance techniques start to take shape in the late 1980s to early 1990s. Innovations in digital guidance systems and mud-driven drill heads have advanced rapidly in the last 10 to 15 years. HDD has applications in well drilling, both extraction and remediation, and in utility pipe installation. There are two primary applications for horizontal directional drilling. First is well drilling and then remediation well development, and the other is utility pipeline installation. This graphic here below shows a layout of two pipes that were installed by horizontal directional drilling to remediate a subsurface contamination fuel oil plume. New material sampling and new material injection can take place, while removal of old contaminated material also is part of the process. Over on the right, you can see a layout of pipeline installation being accomplished by horizontal directional drilling. Here you see the borehole. You see that pipeline going into the mud, into the hole. That's the borehole. And then the reamer is about to be placed on the end of the pipe, and the pipe will be pulled through where the borehole, through the pilot borehole. Cost benefits of horizontal directional drilling. Some of the primary benefits are beyond just the price, and in some cases the complexities of the project are just simply so great that the undertaking is just not possible without HDD technology. So there's an opportunity cost or an opportunity gained by horizontal directional drilling. HDD allows drilling and development of a single well that would require numerous very expensive vertical wells that are often over $1 million each to develop, versus just a single well developed for perhaps double the cost of a single vertical well. Like, so if it was double the price, it'd be $2 million versus $1 million. Remediation wells are often in congested urban or industrial areas that are still in business, where conventional wells are simply not possible, or at least not at a reasonable expense. There's a big cost to the human impact and to the environment. For pipeline installation, take this real-world example. Cost of a conventional open trench installation of 10-inch water pipe. Say it's $80 per lineal foot, and it's at 100 lineal feet of installation. That would be $80,000. The site is in a sensitive riparian area with a side slope and requires extensive post-construction remediation totaling $150,000. That would bring the cost of the installation up to $230,000. Installation by HDD, by comparison, would be something like $150 per lineal foot, mainly the price of bringing special equipment and a special operator and all of the setup. So that would be $150 per lineal foot, with only, say, $10,000 spent on remediation versus the $150,000. So that would bring the total for installation for HDD up to $160,000. So clearly, HDD has a benefit in certain situations. Technological innovations continue to improve techniques and processes. The project types, sizes, and scope have advanced significantly in the past 10 years. Again, projects that were perhaps not possible or were possible only at a very high cost of impact and actually monetary costs are greatly improved now by HDD techniques. Projects that were just not deemed feasible before now can be accomplished. Large pipelines that cross rivers and waterways, contamination sites that lie under urban or industrial areas, and resource extraction in environmentally sensitive areas. Now, these types of projects can be taken on because the wells could be drilled from many miles away without a cost to the local environmentally sensitive areas. Of course, with more complexity, it requires more technology, and so that brings in the need for guidance systems and training simulation, as you can see here. Guidance systems include surface tracking, which are some of the technology is a little bit older, but still being improved all the time. DC coils and AC coils, walkover radio tracking, and GST or gyro steering tool technology that uses gyroscopic tracking. The major benefits of HDD. There's a much smaller construction footprint, a lower impact to environment and human activity, generally much higher rate of production due to lower impacts in all areas. Again, these types of projects have to be compared with conventional techniques. The main considerations and drawbacks of utilizing HDD include much higher level of reliance on the technology, the requirement for specialized equipment with specially trained operators. There's a longer setup time until production actually begins, and the cost per unit distance of installation, this is regarding utility pipeline installation, can be higher if impacts are not a consideration. The project must be analyzed to decide if the cost-benefit ratio justifies the extra expense. Generally, there's a higher cost-benefit ratio when there are more environmental and human impact issues and complexities that are far worse using conventional open trench or multiple well techniques. So, if there are more issues due to environmental factors and human impact, then this is when you would make a case for using horizontal drilling technology. A couple of innovative projects that have happened in the last maybe 5 years, and they're very innovative in their scope and their size and the use of technology. There was an innovative project in Bolivia in which there was an 8,850 foot 32-inch single drill HDD gas pipeline across the Rio Grande in Bolivia. Very sensitive area, high risk of hydrofracking, and a lot of complexities with installing such a large pipe in inside of a water table. And here's a link to see that project and read the entire paper on it. Also, a great project in China where they had to cross the Yangtze River. It was one of the longest HDD pulls ever accomplished. And here are my references. Thank you, and I hope you find the topic interesting and you do further research. It's a very useful technology that we use a lot and we're relying on more and more every day.